Have you ever wondered what it would be like to travel faster than light? It's a tantalizing thought, isn't it? One that has sparked the imagination of scientists and science fiction authors alike for decades. Despite the fact that we don't yet have a definitive answer, the prospect of such a revolutionary development has far-reaching implications. In our video today, we'll delve into the scientific principles behind the concept of exceeding light speed. We'll also ponder the potential effects such an invention could have. From Einstein's theory of relativity to the proposition of wormholes and warp drives, we'll traverse the galaxies of knowledge together. But remember, theoretical physics is a tricky beast, and what seems impossible today might just be tomorrow's reality. So strap in, everyone, fasten your seatbelts, and prepare for a journey into the realm of the impossible. Or maybe not so impossible. According to Einstein's theory of special relativity, the speed of light is the ultimate cosmic speed limit. This groundbreaking theory, proposed over a century ago, fundamentally altered our understanding of physics and the universe itself. So, what does this mean? Well, in layman's terms, it establishes that nothing in the universe can travel faster than light. Let's break it down. The speed of light is an impressive 186,000 miles per second. That's fast enough to circle the Earth 7.5 times in just 1 second. Now imagine trying to exceed this speed. According to Einstein, as an object with mass accelerates towards the speed of light, its energy increases, and therefore its mass increases. This would require an infinite amount of energy to reach the speed of light, making it an impossible task. But why is this the case? Well, it's all about space-time. Einstein proposed that space and time are not separate entities, but are interwoven into a single continuum known as space-time. Light always travels through this space-time fabric at a constant speed, regardless of the observer's perspective. This is why time appears to slow down as you approach the speed of light, a phenomenon known as time dilation. So, if light speed is the universe's speed limit, how could we possibly hope to travel faster? This is where things get really interesting. Remember, Einstein's theory says objects with mass can't reach or exceed the speed of light. But what if we could find a way to cheat the system, to bend the rules without breaking them? In our next scene, we'll delve into some of the theoretical concepts that might allow us to do just that, including wormholes and warp drives. So stay tuned as we explore the fascinating possibilities and potential implications of faster-than-light travel. One possibility is to use wormholes, theoretical tunnels that could connect two distant points in space-time. Now imagine you're holding a piece of paper and you mark two dots on it. If you fold that paper so the two dots meet, you've essentially created a shortcut. This is the basic idea of a wormhole. It's a kind of cosmic backdoor, a tunnel through the fabric of space and time that could, in theory, allow us to travel vast distances almost instantaneously. But wormholes are tricky. For one, we've never actually observed one. They exist purely in the realm of theoretical physics. And even if we did find one, they're predicted to be incredibly unstable, collapsing the instant anything tries to pass through, unless they're propped open by something called exotic matter. But that's a topic for another day. Now, what about warp drives? Well, instead of taking a shortcut through space-time, a warp drive would essentially create its own road. The idea, first proposed by physicist Miguel Alcubierre, involves expanding space-time behind a spaceship and contracting it in front. This would create a bubble of flat space-time where the spaceship sits, allowing it to surf the wave of warped space-time. Sounds brilliant, right? But there's a catch. Creating this warp bubble would require negative energy, a form of energy that, as far as we know, doesn't exist. And even if it did, we'd need an astronomical amount of it. Plus, there's the small issue of potentially obliterating anything in our path when we arrive at our destination. However, there are many challenges that would need to be overcome before we could make faster-than-light travel a reality. But isn't that the beauty of science? It's all about pushing the boundaries of what we know, and who knows what we might discover in the process. So, while we might not be hopping on a warp-powered starship or diving into a wormhole anytime soon, the journey of discovery continues. For example, wormholes are thought to be incredibly unstable, and they would require a huge amount of energy to keep them open. Just imagine trying to hold open a rapidly closing portal while simultaneously navigating a spaceship through it. Talk about a high-pressure situation. Then there's the issue of negative energy, an elusive substance required to power warp drives. The concept of negative energy is like an enigma wrapped in a mystery, nestled inside a paradox. It's a theoretical substance that we've yet to observe or even prove the existence of. And let's not forget about the potential effects of faster-than-light travel on the human body. We don't know how our bodies would react to such extreme speeds, and it's possible that the experience could be fatal. But the challenges of faster-than-light travel aren't just technical, they're also ethical and philosophical. If we could travel faster than light, we could potentially encounter civilizations far more advanced than our own. What would this mean for humanity? Would we be prepared for such an encounter, or would it lead to catastrophe? Then there's the possibility of time travel. According to some interpretations of Einstein's theory of relativity, faster-than-light travel could allow us to travel back in time. This opens up a Pandora's box of potential paradoxes and unintended consequences. What if you were to go back in time and inadvertently change something that alters the course of history? And if all that wasn't daunting enough, there's the small matter of potentially destroying the universe. Some theories suggest that faster-than-light travel could create ripples in the fabric of space-time, leading to catastrophic consequences on a cosmic scale. So as we can see, the challenges and consequences of faster-than-light travel are immense and varied. They span the realms of science, ethics, and philosophy, and they force us to ask some hard questions about our place in the universe. And we could even accidentally destroy the universe if we're not careful. So, while the idea of faster-than-light travel is exciting, it's also important to remember that it's a double-edged sword. This is not a realm we can enter lightly. The exhilarating prospect of traversing galaxies in the blink of an eye comes with a hefty set of potential risks and rewards. On one side of the blade, the benefits. Imagine the possibilities. We could reach out to the farthest corners of the universe, make contact with alien civilizations, and glean knowledge that could revolutionize our understanding of the cosmos. We could colonize distant planets, ensuring the survival of our species far beyond the lifespan of our sun. And of course, we could uncover the mysteries that lie in the deep, unexplored expanses of space, enriching our grasp of the universe and our place within it. But then, we flip the sword. On the other side, the risks. The possibility of encountering advanced civilizations is as terrifying as it is thrilling. Are we ready for such contact? Or would we be like ants meeting humans? And let's not forget the potential for time paradoxes. If we could travel faster than light, we might also travel back in time, leading to paradoxes that could unravel the very fabric of reality. Moreover, the sheer energy required for such travel could be catastrophic if misused. Theoretically, a mishap with a warp drive or wormhole could lead to unimaginable disaster, even potentially ripping apart space-time itself. We're talking about a power that could inadvertently obliterate entire star systems, if not the universe. And so, we stand on the precipice of a vast, unknown frontier. Faster-than-light travel is a tantalizing prospect, a dream that could elevate humanity to the next level of cosmic exploration. But it's a dream that must be pursued with caution, wisdom, and a deep respect for the potentially devastating forces we're flirting with. As we continue to push the boundaries of our knowledge and capabilities, we must also remember our responsibility to do so wisely. The universe is a vast, beautiful mystery that we're just beginning to unravel. As we venture forth into the unknown, we must tread lightly, armed with wisdom, prepared for the unimaginable and respectful of the cosmic forces that govern our existence. We need to use our knowledge wisely, and we need to be prepared for the unknown. Thank you for watching. We've journeyed through the intriguing realm of faster-than-light travel, from the cosmic speed limit set by Einstein's theory to the speculative solutions of wormholes and warp drives. We've danced with the paradoxes of time travel and flirted with the potential of unforeseen encounters in a universe teeming with mystery. We've also grappled with the daunting challenges and potentially catastrophic consequences of such a technological leap. The universe, as we've often seen, is a double-edged sword of infinite possibilities and profound caution. We must tread carefully as we push the boundaries of our understanding and capabilities. So, if you found this journey as captivating as I have, consider giving this video a like and subscribing to the channel. We'll continue to explore these mind-bending concepts and more. As we part ways, remember to keep your eyes on the stars and never give up on your dreams.